So now we go to more specifics. We'll take a lot of examples on how to solve an inequality. All the common properties that we learned some time back, we use them again and again till it gets into your system as to how to solve an inequation in a simple manner and try to get the solution of this particular example, these various examples that we are going to do right now. There may be a few examples where a little additional input will be put in, a few simple extra concepts which may be required, but nevertheless there are enough number of examples to reinforce what we have taught. So let's move ahead. So let's take this particular example. Solution of the inequality 5 minus 2x the whole divided by 3 is less than or equal to x by 6 minus 5. Let's solve this and see what the solution is. So we have 5 minus 2x the whole divided by 3 is less than or equal to x by 6 minus 5. Which means, of course, that the left-hand side is either less than the right-hand side or it is equal to. So let's see how to solve this. First of all, let's make this simpler. So in the next stage, we have 5 by 3 minus 2x upon 3. We split up less than x by 6 minus 5. Now we have not yet started using the rules which we mentioned earlier. So we have 5 by 3 minus 2x by 3 less than or equal to x by 6 minus 5. So we add and subtract and all that. In simple words, we collect all the x terms together and all the y terms together. So let's take the x term, this one this way, and 5 by 3 to the other side. So in the next step, we have minus 2x upon 3 minus x upon 6 minus 5 and minus 5 by 3. We just transpose the x by 6 and 5 by 3 to the other side. And the signs have, of course, changed. Now, what do you think would happen to this? Remember the first rule. You're subtracting or adding some number, negative or positive. It seriously does not matter. The inequality continues to remain the same. That is less than or equal to. Let's simplify this, which means you're going to take the LCM and do it. So we have 6 by 3 minus 2 into 4 minus 4x, and you have minus 5x upon 6. There is no rule that we have applied of inequality, so it continues to remain the same. Here again it says 3 into minus 5 minus 15 minus 5 minus 20 upon 3. So now, how do we simplify this further? Now, to separate this from this, we are going to multiply by the reciprocal of minus 5 by 6, which means that x, and here you have minus 20 by 3 into minus 6 by 5, because you multiplied by the reciprocal. And caution, what have we done in the previous steps? Nothing. We added, subtracted some number. We have to just keep on putting on the left less than or equal to sign. The inequality continues to remain the same. But here we have multiplied both sides by a negative number, or in simple words, we have divided by minus 5 by 6. And this thing changes to greater than or equal to. So we have 3 and 2. So minus 40 by 5, 8. And here we have x is greater than or equal to 8. This is the answer for this. Okay, so we have x greater than or equal to 8, x less than or equal to 8, x is equal to 8, or none of these. And we have solved this. Let's see what the solution of this could be. So yes, we have x greater than or equal to 8. Right? So a simple way in which how we can solve a simple inequation. Let's take up another case, the next case. Find the range of real values of x satisfying the inequality 3x minus 2 greater than 7 and 4x minus 13 greater than 5. Let us understand what this question actually means. When you're talking about range of real values, the inbuilt understanding is that all those values of x which simultaneously satisfy this inequation as well as this inequation. That has to be taken care of. Hence, we duplicate the process of what we did in the previous example. So we need to solve both these inequations if not simultaneously later on. So let's take this case of 3x minus 2 and greater than 7. So we have 3x minus 2 greater than 7, and we need to take 2 to the other side, which we say we add 2 to both sides. So we have 3x, there is no change in the rule, 7 plus 2, 9. And then we divide both sides by 3, which means that you're going to take the 3 to that side, divide it, 9 by 3. What happens? You're dividing by a positive number. There is no need to worry. We go on. X is greater than 9 by 3, which means that x is greater than 3. But we are talking about range of values. So these are only those values which satisfy this particular inequation. We have to couple them with those values which satisfy this inequation. So let's take this. So we have 4x minus 13 and greater than 15. So again we transpose it to the other side. So we have 4x greater than 15 plus 13, 28. And then to separate this 4 and this x and to isolate x, since they are multiplied, we divide. So we have x and greater than 28 by 4, and it continues to remain x greater than, because yes, we have divided by a positive number, not a negative number. No cause to worry. So we have x greater than 7. So we have to find out those values which satisfy both these. So this could involve 4, 5, 6, 7, 8 and so on. This could involve 8, 9, 10 and so on. So we need to take up values that are simultaneously satisfying. So we take all these. That means we deal with all the numbers which satisfy x greater than 7. So that is, if x is greater than 7, it also means x is going to be greater than 3. So these set of values which are greater than 7 satisfy this inequation as well as this inequation. So we have these options: x is greater than 3, x is greater than 7, x is less than 7, and x is less than 3. So apparently from here, this is the option. So let's check the answer. Yes, we have x is greater than 7. So we have x greater than 7. Very good. Now, let's take up more examples, since we seem to be getting an idea of how to go about solving. The best ways to practice more. So we have this case. Now, what is this? This is absolute value of a number, which could mean, say, example. So let's have a quick understanding what exactly. Maybe you might be knowing it, but let's have a recap. Suppose you have a number minus 5 and its absolute value, which is also called modulus, is 5, and absolute value of 5 is also 5. So if I say absolute value of a particular number is 5, then it could mean this number inside, not the absolute value. The number inside could be minus 5, or it could even be 5. It could be minus 5 or 5. So whenever we take a number, so basically you have absolute value of, or modulus of x plus. Absolute value is also called modulus, and these brackets are called mod brackets or modulus bracket. So here in words, this means we have a number x plus 1 by 4 whose absolute value is greater than 7 by 4, which could mean that x plus 1 by 4, as in similar to this, could be negative number or it could be a positive number. So hence, like the previous example, it's as good as having two separate inequations and solving them simultaneously. So let's take the case now. Hence, just as we said absolute value of x is 5, then x could be minus 5 or x could be 5. But here we are dealing with equalities. Now when we take to this, we have, which means x plus 1 by 4 is greater than 7 by 4. That means the number inside, if you take the positive part of 7 by 4, it continues the same relationship. Or there is another possibility that the number inside this could be x plus 1 by 4. It continues. It could be less than minus 7 by 4 because we are considering the negative possibility. So we need to solve both these simultaneously. So we have x, again we subtract 1 by 4, which is the same as taking it to the other side. So x is greater than 7 minus 1 by 4, that is 6 by 4, which is the same as 3 by 2. Or x plus 1 by 4, it could be x is less than minus 7 by 4 minus 1 by 4. Again, there is no change at this stage because we are just subtracting the same number. Now this turns out to be x less than minus 8 by 4, that is, we have minus 2. So we have a possibility of either x being less than minus 2 or x being greater than 3 by 2. Let's check whether it's valid or no. Let's put x as 3 by 2. So we get what? 3 by 2 plus 1 by 4, which happens to be so x is any number greater than 3 by 2. So let's take 5 by 2. So we have 5 by 2 plus 1 by 4. So 4 by 2. So you have 11 by 4. Yes, 11 by 4 is greater than 7 by 4. So any number greater than 3 by 2 is satisfying this inequation. Let us take here. Let's take a number less than minus 2 and substitute over here. Take a number less than minus 2. Maybe we could take, say, minus 3. So we have minus 3 plus 1 by 4, which turns out to be minus 11 by 4. And the absolute value of minus 11 by 4 is 11 by 4. And this 11 by 4 is greater than 7 by 4. Hence, any number less than minus 2 is satisfying this inequation, as well as any number greater than 3 by 2. Hence, we have a solution wherein we have x greater than 3 by 2, any number greater than 3 by 2. So in this case, 5 by 2 is satisfying the inequation that absolute value of 5 by 2 plus 1 by 4 or modulus 5 by 2 plus 1 by 4, which turns out to be 11 by 4, is greater than 7 by 4. So it could be 7 by 2, 5 by 2, 3.5 by 2. All such numbers will satisfy this inequation, as well as any number less than minus 2, minus 3, minus 2.2, minus 2.3, point whatever. All the numbers less than minus 2 are also satisfying. So let's check what options we have here. You have x less than minus 3 by 2. This is definitely not valid. X less than or equal to minus 2, x greater than 3 by 2. Yes, this is our answer. So we have a combination of two sets. Of course, each of these, unlike the previous examples, we take together those values which satisfy both simultaneously. Here we consider case of either or. Either the value should be less than minus 2 or the value should be greater than 3 by 2. So any real number less than minus 2 or any real number greater than 3 by 2 will satisfy this particular inequation. Now let's check whether what we have done is right or no. Let's check the answer. Yes, we have x is less than minus 2 or x is greater than 3 by 2. This example could be a little dicey, so let's check whether we have more examples of the same kind and solve them. Yes, we have one here. We have absolute value of x plus 1 by 5 greater than 11 by 5. What is the other name of absolute value? Yes, you're right. We can call it modulus of x plus 1 by 5 greater than 11 by 5. So let's go about doing the same way. Yes, so we have x plus 1 by 5 is greater than 11 by 5, which could mean x plus 1 by 5, that is the number inside. Suppose it is positive, it continues to be greater than 11 by 5. Or if that number inside is negative, it could be less than, the inequality sign changes and you have x plus 1 by 5 is less than minus 11. Same thing would be valid even if it was given greater than or equal to. This one changes to less than or equal to. We solve this, x plus 1 by 5 greater than 11 by 5. So that means x is greater than 11 minus 1. 10 by 5, x is greater than 2. Here this will be x continues to be less than, because you're only subtracting, is less than minus 12 by 5, which turns out to be minus 2.4. So either x is greater than 2 or x is less than minus 2.4. Whatever we did in the previous example is what we are doing over here. We have taken x plus 1 by 5 greater than 11 by 5, and we consider the range of numbers. When you take 11 by 5 as negative, that is minus 11 by 5, immediately the inequation sign changes. Rest everything remains the same. So we have a combination of x greater than 2 or less than minus 2 by 2.4. Remember, the values are not both of these being satisfied simultaneously. Either the number could be greater than 2 or any number less than minus 2.4. Anything in between is not going to satisfy this inequation. So we have among these, we have all these options. So obviously this one is valid over here. So let's check what the answer is. Yes, we have x greater than 2 or x is less than minus 2.4. So these were a couple of examples on modulus or absolute value. Let's take a few more simple examples. Okay, so now we have this slightly bigger inequation. We have a combination of 3 inequations, and we have to find out various among these values. Now here we will not be able to solve all these together because the question is not about solving the inequations. We need to find out among these which set of values would satisfy all these inequations simultaneously. So we follow the simple logic of substituting each of these values in each of them. Now that's a very tall order. Imagine 4. You have 4 into 4 into 4 3s are 12 plus 5 17 values. We can't substitute in each of these. So we need to, and since the exam format is an MCQ process, we need to eliminate all the absurd values among these. So we have this inequation 6x plus y is greater than or equal to 18. X plus 4y greater than or equal to 12, 2x plus y is greater than or equal to 10. We need to solve this, and we want to check which among these situations will be followed. Now, ideally, as I said, the logic is about substituting each of these values over here. But let's do the concept of trying to eliminate. So we remember these are all greater than. Now look at the last one out here. We have 0, 18, 12, 0, 4, 2, 0, 0. We have 0, 0. In all probabilities, substituting 0, just substitute in the first one. We have 6 into 0 plus 0. 0 plus 0 is 0, which is definitely not greater than or equal to. We need have to check for the remaining because the first equation itself is not satisfied by one of the values. So this is out of question. So this makes no sense. Then let's check up other values. Now also take a hint of see the inequations. Two of the inequations, or even if one of them has a bigger coefficient for x, 6, and here it is y. So it is 6x plus y. So if you look at a couple of these examples like B and C, they have at least one value where we have x is 0. So it sounds a little absurd that it will satisfy this inequation. Let us substitute this value. Say x is 0. So we have 6 into 0 plus 3 and 18. And you have 3 and 18. 3 is definitely not greater than or equal to 18. So this itself makes no sense. So this is out too. Similar to that, we have a case like the 0, 10 in this. Let's check this also in one of these inequations. Yes. Say in this one. So we'll take this 0, 10 and try to substitute in this. So we have 6 into 0 plus 10 and we have 18. So 10 and 18 again, 10 is definitely not greater than or equal to 18. So this is out too. So among these four possibilities, logically this seems to be okay. Even this has a 0, 18, but the y coordinate is so large. So if you substitute over here, you get 6 into 0 plus 18 and you have 18. This becomes 18 and 18, which is definitely equal to, and hence it is valid for greater than or equal to. So this is valid. And logically, obviously, all 4 are not wrong. So 3 of them could be wrong. So we can take this. But as I told you, the logical, mathematical logic behind is that each of these values should satisfy each of the inequations. But within the time format that we have, we cannot follow the process of substituting these 4 into 312 plus 517 values. So we do a quick recap and observe the numbers. This very clearly is absurd. These two probability absurd. So we could substitute these values and see that they don't seem to be valid. So this one seems to be the valid one. So let's check what the answer is. Yes, this one seems to be the answer. Now this sum is a little off track compared to the previous ones because we are not actually solving an equation, we are substituting the values. So to understand this better, let us make this a little more strong. Let's take one more example of the same kind. So here we have similar kind of thing. On solving the inequalities, 5x plus y is greater than or equal to 15, x plus 6y is greater than or equal to 18, 3x plus y is greater than or equal to 9. We get the following situations. Now, let's see. Now, obviously, this makes no sense because there are 2 zeros over here. Let's substitute over here and see 5 into 0 plus 0. And we have 15, 0, obviously greater than or equal to 15 is out of question. So this is out. Look at the 0, 3. Substitute over here 5 into 0 and you have plus 3. And we have 3 and 15. Definitely not greater than or equal to 15. So this is out of question. The same 0, 3 features here. So this makes no sense. So in all probabilities, this could be valid. We can just roughly substitute over here 5 into 0, 0 plus 15. Yes, so we have 15 is greater than or equal to 15. Similarly, this could satisfy all these other values are bound to satisfy logically because the remaining answers are wrong. So this has to be right. And as I reinforce, logically, it means if you have been given a lot of time and you have been asked to do to this sum, you have to substitute each of these values. But from your exam point of view, we introduce a process of eliminating absurdities. So the only one that we can zero in on this. Again, let's check the answer. Are we right or no? Yes, we seem to be right because the remaining 3, as I showed to you, are absurd. So this seems to be the most valid kind of an answer. So we did a few examples on solving inequations, on modulus, absolute value, and even this. So let's check exactly what a linear equation is. What is a linear equation? Why do we call this kind of an equation? So suppose you have something like 2x plus 3y is, let's start with an equation itself. It's 7. Now, if you see, this is x raised to 1, y raised to 1. These are the variables, the unknown quantities. They have been raised to the index 1. So whenever you have this kind of an equation, when you try to plot a graph, you're bound to get a straight line, as we will see in the remaining examples. So whenever you have an equation of this kind, ax plus by is equal to c, where x and y are the unknowns, a and b and c could be constants, like a could be 2, b could be 3, c could be 7. So this kind of a relationship is called a linear relationship, simply because when you represent this relationship in the form of a graph, you get a straight line. So much the same way, it's a linear equation in 2 unknowns, or we say it's a linear equation in 2 variables. Remember, a and b are not unknowns. They are some constants like 2, 2.5, 3, 7, any such numbers. But x and y keep varying. Much the same way, we can extend this to the concept of inequalities too. So if you're talking about inequality, it could be ax plus by could be less than or equal to 7. Ax plus by could be greater than or equal to c, or ax plus by could be less than c. Ax plus by is greater than C, or these. All these 5 are linear relationships. They express a linear relationship between two variables x and y. Let us check among these which ones seem to be valid. Now, obviously this one seems to be valid. This is absurd because this actually means there is no plus sign in between, and although x and y have been raised to 1, when you multiply together, the total index or the total degree of the variable is 1 plus 1, 2. So this is definitely not a linear equation. This again is not a linear equation because it's axy and not ax. Again, this is bxy, so this is not valid. So this is a linear equation. Let's check what the answer is. Yes, we are right here. Ax plus by is less than or equal to c because the remaining are absurd relationships. When not absurd relationships precisely, with respect to this question, it's an absurd relationship.